Hi students, welcome back. Today we are going to look at implementing a queue using two stacks. Okay, so let's see the problem statement first. The problem statement says implement a first in first out, which is queue using only two stacks. The implemented queue should support all the functions of a normal queue, which is push, peek, pop and empty. So the queue, which is called my queue in this case, should contain all the operations. Push, it should push an integer x. Pop, it should remove the first in element from the queue following FIFO, which is first in first out. Peek also should follow FIFO and show the first element of the queue. Empty should return if the queue is empty or not. Okay, and we are allowed to use only standard operations of a stack. We can't use a regular queue data structure which is already available in Java. Okay, so let's look at an example. So the example says uh, we are pushing a element 1 to the queue. So the queue now has 1. Now when we push another element, queue has 1 and 2. When we peek, it should show the first element, so it is showing 1. But the queue will still have 1 and 2 at this point. When you pop, 1 is removed, so the queue has 2. When you check if the queue is empty, since the queue still has 2, it is saying it's false. So let's see this with an example, how to implement this. So we have to take two stacks, correct? So queue is a FIFO, first in, first out. Stack is a LIFO, last in, first out. It's completely opposite of queue. Queue returns the oldest first, stack returns the newest first. Okay, let's say we have two stacks. So to return the oldest first, we have to have a stack which has elements in the reverse order basically. So let's call this stack with oldest first, and this is a regular stack which is a LIFO, last in first out. So let's say we have to insert these three elements to the stack. What we will do every time we need to insert is we will empty the contents of this stack, we will insert our new element and we will push back the contents to this stack. Why are we doing that? Because we want the last element on the top, oldest element on the top, so that when we return it, we will follow the FIFO. So let's say we are inserting 1. When we are inserting 1, there is nothing to empty here. So nothing is added to this stack. 1 is added here. Okay, and if there was anything else, we would have added it. Okay, now let's take a look at inserting 2. When we are inserting 2, what we should do first? First we should empty this stack and add it here. Okay, next add the current element whatever we are inserting to this stack. Then bring back elements from this stack to this stack again. So 1 comes here. If you see, since we put in the other stack and brought it back, the order is reversed and oldest became on top automatically. Now, when we try to insert 3, again we follow the same logic. We push 1, we push 2, then we insert the current element, then we move elements from here to here. If you see, since we are doing the reverse operation, the order is clearly maintained. Now if we add 4 and 5, it's the same thing. Now for the other operations of pop, we just remove the top element of this stack. And peek, we just peek the top element of this stack. Is empty, we just return if this stack is empty or not. This is just a helper stack. We are maintaining our FIFO order in this stack by using this stack. Okay, so let's try to implement this. Okay, let's say, so this is what LeetCode has already given us. Okay, let's define a queue, sorry, stack, two stacks. We need two stacks. So the two stacks are integer stacks. One is a regular stack and one is a stack with oldest on top. Okay, stack with oldest on top. Okay, now, okay, instead of, let's initialize them in the constructor instead of initializing here. Okay. Okay. Now we have both the stacks. Now when we push an element, what should we do? While the stack with oldest on top, while that is not empty, okay, while that is not empty, we push it to the second stack, which is our regular stack. Stack dot push stack with oldest on top dot pop. So we are popping every element from this stack and pushing there. Okay. So we moved all our elements from this stack to that stack. Then to the stack with oldest on top, we push whatever element we are given. Then we bring back whatever we have pushed to the other stack. The other, while it is not empty, the not empty check is important, otherwise it will throw a null pointer exception. So we have to bring back elements to the oldest on top stack. So, okay, that's all. So that is this maintains the order with stack with oldest on top, and popping and all is just a regular operation now. Peak is, you just call the peak of it. Okay. Is empty is also is empty. Okay. So when we are pushing the elements to the temporary stack, inserting our element at the bottom and bringing back our elements. Pop is, since we are maintaining the correct order in oldest on top stack, we always have the elements. So we just pop and peak and is empty. So what is the time complexity of this? The pop, peak and empty are order of 1, because we are just returning the top elements of the stack. Whereas for push, we are moving it to another stack, bringing back another stack. So if the stack is full, it would be order of n. Similarly, the time complexity also would be order of n because, sorry, space complexity would also be order of n because we are using additional stacks. Okay. Let's run this code. Yeah. Yeah, it got submitted. That's all for today. If you have any questions, please do leave a comment. Please like, share and subscribe our videos. Please help us spread the word. Happy coding.